All right, looks like we've got a full house, so we'll go ahead and get started. I'll keep that poll up just in case we get any new folks who join on. I want to answer a couple quick questions. And in the meantime, thank you, everyone. Good afternoon. We're excited you're able to join us today for our February edition of Kenworth Northeast Training Academy. We appreciate you taking the time to hop on the call with our friends from Road Warrior to take a deeper dive into the nuances of after-treatment. My name is Melinda. I'm the Director of Marketing here at Kenworth Northeast. And more importantly, we are joined by David German from Road Warrior, and he'll be leading us through today's session.
Thanks for inviting me, and thanks for everyone taking the time.
So just some quick housekeeping things. Cameras and audio are defaulted to off to reduce background noise and distractions during the session. If you do have questions, we ask that you pop them into the Q&A anytime during the call. And then at the end, David will go through and answer the questions before we jump off. Let's see here. So just so you're aware, if you haven't seen, we do have a number of events scheduled through 2024. Obviously, today we've got Road Warrior. Later on this year, you'll see next month, actually, we've got a series that we're doing with A-Line that are in person at a number of our locations. We also have Hendrickson, Horton, Meritor, and some others lined up. And then over the coming months, I'll be continuing to schedule these out through about October of this year. So we've got a lot of great vendors. Some in person, some are virtual, with lots of great content to come. So the website, kenworthne.com/training-academy. That link will also be available to you in a follow-up email after today's call as well. So with that, we'll go ahead and get started. David, do you want to go ahead and take control of the...
Sure, I'll share my screen. So let's say yes, and we'll go to screen one. And do you see the main presentation screen okay?
Yes.
All right, perfect. Well, again, want to thank you, Melinda, for inviting me, and thanks to everyone for taking the time today. My name is Dave German, Sales Director here at Road Warrior. Just going through this presentation today. Just give me a second here. Hold on. There we go. Sorry about that. So basically, just want to tell you a little bit about Road Warrior. We're born off highway, part of the DCL group of companies, and we were the first and the leaders in the aftermarket to offer DPF and catalyst alternatives for trucks, buses, and construction equipment. We have the largest product catalog in the market. We are leaders in developing new hard to find parts and accessories. So if you ever try to cross-reference an OEM replacement and you can't find it, please contact your Kenworth Northeast rep, and they can check with us, and we can get those designs communicated through our R&D department. And when the OEMs were out of stock, Road Warrior had the inventory. So as part of the DCL Technology Group, with over 35 years of catalyst and after-treatment experience, you're dealing with an expert where catalysts is and DPF coatings is what we do. And what separates us from some of our competitors is our manufacturing expertise. Through the DCL Technology Group, we are truly vertically integrated, manufacturing our substrates, doing the brazing and coating, and the final canning and fabrication in-house. So we're able to give you a extremely high quality product at a very aggressive price in the marketplace. But that's enough about Road Warrior. Just want to switch over and start talking about the after treatment system, which is what we are here for. So just opening up this slide here, we'll focus on all the different main components that we're going to be talking about. So first, we'll have the DOC here, diesel oxidation catalyst. I'll spend some time talking about that because it's probably the most misunderstood and mis-troubleshot component on the after treatment system. So I'll talk a little bit about its relationship and how it promotes passive and active regen. Then we have the diesel particulate filter. It's technically what gets the blame most of the time. It tends to be what fails and cracks, and you see that bypass and why the truck ends up in the shop. So we'll talk about ways to identify your DPF, and that's ways to fix it right the first time. Then we'll also talk about the SCR system and talk a little bit about depth fluid crystallization, which tends to be enemy number one. its relation to diesel exhaust fluid and obviously exhaust gas recirculation. So as this slide opens up here, again, these are all the major components that we have, the DOC, the DPF, and the SCR. As I mentioned, the DOC is probably the misunderstood. It's that catalyst coating that really keeps that filter clean. The DPF's like a big garbage can. It traps and blocks all that soot, but it has to go somewhere. And it's that DOC with its chemical coating that promotes that regeneration. So the biggest problem in the industry is the DPF. We're going to have some slides here, just which will illustrate how you tell when the DPF is compromised. But that DOC, because the chemical coating is the working part, a little harder to identify. So we're going to talk about some tips and things that we can look up, some data from your ECM where it'll tell you when that DOC is beyond its useful life. We have DEF fluid we'll touch on. It does expire, so we'll highlight some things to look on there and DEF fluid filters. The SCR system is downstream. Things like crystallization. We'll have some pictures of a look at some different failure modes. And we also have the EGRs, which is exhaust gas recirculation, and things like coolant leaks and turbo failures are detrimental to the after treatment system. So it's all related. So the DPF, it's like a big garbage can. It traps and blocks all that soot. But when it fails, it's usually not the root cause of the problem. It's usually 9 times out of 10 something happened upstream, and that DOC through its chemical coating is really the driving force behind passive and active regen. So with that being said, I'm just going to get to the next slide to elaborate a little bit more about passive and active regen. So as mentioned, there's 2 types of regeneration that occur on a vehicle. You have your passive regen and your active regen. The passive regen is the primary source of regeneration you want on the system. I call that free regeneration because it's relies on the heat and the exhaust gases, but it is also duty cycle dependent. So that's when the vehicle's going down the road, it's working hard, the temperatures are nice and hot, and then that DOC takes that heat and those exhaust gases, and it's able to oxidize the soot. Oxidizing is just a fancy way of saying it's regenerating the filter. It's taking that solid carbon and burning it off into a gas, and it's self-cleaning. So ideally, you want your truck going down the road, and the filter is filling with soot and emptying itself out, filling it with soot and emptying itself out. Everybody's happy, the driver's happy, the filter's happy, and everything's working perfectly when you have a good duty cycle. However, it is duty cycle dependent, like I mentioned. So when you have a traffic jam, or the truck is idling, waiting to unload its cargo, or you have some difficult applications like garbage trucks or school buses that have a lot of idling, stop and go, that's when the system can get backed up, and essentially, the filter does have what's called soot loading capacity. So if it is idling for an extensive period of time, the filter will fill with soot, and it'll get full, and then it'll trip a high back pressure sensor saying, hey, I'm not sure what's going on here. The truck's not working hard enough, or the vehicle's not working hard enough. We have to clean out this filter. So it's going to go into what's called an active regen mode. There's 2 ways that can happen. In some of the older vehicles, they had a manual button that could be pushed, or a lot of it's done automatically. The ECM will go to will make the engine go to high idle. It'll have a doser injector, which will spray diesel fuel. And then that DOC, again, is very important. It's going to ignite that diesel fuel, creating essentially a little fire in front of that filter to artificially spike the temperatures up to self-clean that filter. And that's what we call active regen. And I call that paid regeneration because we're burning extra diesel fuel to get the job done. Now, what we want is passive regeneration to be the primary source, and that's when you have a healthy DOC and a good duty cycle. And the active regen system is like your backup system. It's like you're using your primary brake and your emergency brake. So if your truck is actively regenerating all the time, or more than normal, that's usually a sign or signal that something's going wrong. So if the truck is actively regenerating more than normal, you want to ask yourself a couple of questions. When was the last time I cleaned my DPF? If it's been a year or 2 or longer that you haven't cleaned your filter, again, it has soot loading capacity. So maybe the filter is just consumed with ash. So the ash, which is a byproduct of lube oil consumption that does not oxidize or burn off, it has to be physically removed. That's why we clean the filters. So if it hasn't been cleaned in a while, maybe the filter is just filled with ash. It doesn't have a lot of soot loading capacity. So maybe it's regenerating too often because again, it just needs to be cleaned, and then you can restore that loading capacity. But more commonly, what happens is, say the filter had failed. We'll have some pictures of that, and you put a brand new filter in, and that DOC could have got compromised along the way. If you had a turbo failure, coolant leak, or bad in-cylinder injector, those all can poison the catalyst and can impact the passive regeneration. So if you put a brand new filter in, and your DOC was certified clean, but it could have been chemically poisoned, and all of a sudden you put a brand new filter in and it's trying to actively regenerate all the time. So those are some of the things I'm going to talk about and how to identify that, because it's that DOC. It's what you can't see is what can hurt and harm the filter long term. So again, talking about the DOC, it's the backbone of that DPF regeneration, like I talked about. We make an all metallic DOC, which exceed OEM specs. And with a healthy DOC, again, you have that passive regeneration, so you're going to burn less fuel and have less back pressure. And that DOC is really responsible for keeping that filter clean. So a lot of times when the truck's in the shop and the filter cracks and breaks, we'll have some pictures to identify that. And people blame the DPF, and justifiably, when it's failed, it's pretty obvious to see when that happened, and we'll walk you through that. But you always want to ask, well, why did my DPF fail? And if it failed, it's usually due to an upstream issue, whether it was a failed turbo, bad in-cylinder injector, or coolant leak that can poison the DOC. And then if the DOC gets weak in the knees, it won't be able to regenerate that filter, and then causing recurring problems and failures. So the question, when should I replace my DOC? Here in these pictures that I show here, there's obvious signs when you have a hole melted through it, like you see here in the top picture here. That's obvious. You don't have to be a roll train tech. When you have obvious signs, that's simple to identify. And here you don't want to see this either. You don't want to see any what we call face plugging. The DPF and the DOC face should be blackened with soot because it is exposed to the byproducts of the engine, but it should never be having soot kicking on like that. If you ever get signs of face plugging like that, that means you have incomplete combustion upstream. Could be signs of a failing turbo, exhaust leak, bad in-cylinder injector. Something's going wrong, so you definitely want to investigate a little bit further, because again, if you don't find the true root cause of why your system's failing, you could put a brand new DPF, and if you put it into a bad situation, you'll be back to where you started. So if you've ever had a DPF that failed, one of the questions you want to ask is, have I ever had an EGR coolant leak, blown turbo, or bad in-cylinder injector? And if the answer is yes, then I can tell you that the DOC has been compromised, but you want to say, has it been compromised beyond useful life? And a lot of times people will get their DOCs cleaned, and they say, hey, my DPF's failed and cracked, my DOC was certified clean. But what does that mean? When a DPF cleaner cleans your DOC, they can only tell if it's physically, they can look for signs of face plugging, they can make sure that it's not melted or cracked, but they really can't identify if that chemical coating is still active. And that's really the working part of the catalyst. So a couple things that you can do is, what you want to check for is there's two things that you could do. You want to confirm that the DOC is not dead on arrival. So once you've replace your DPF, it's cracked, you put a new one in, your DOC looks good, so you could put it back and install it. But then most techs will put it through what's called a forced regeneration. And the forced regeneration is with your laptop, and you're looking, there's a temperature 1 sensor before the DOC, there's a temperature 2 sensor after the DOC, and one downstream. And when you're putting it through a forced regen, if that DOC is still chemically active, it's going to act like a spark plug to boom, ignite that diesel fuel, and you see a good rise in temperature. So when it's going through an active regen, it'll go to what's called light off temperature. So you see that inlet temperature between 400 to 500 degrees Fahrenheit. And then once the diesel fuel gets sprayed into the exhaust stream, the DOC will ignite that, and you'll get a good 400 to 500 degree spike. So you'll see that delta T, the difference between temperature 1 and 2 sensors, be about 400 to 500 degrees. So if that's happening, now we've confirmed that your DOC is not still chemically active. It's not dead on arrival. But by doing that, all we've confirmed is that the DOC is good to promote active regen. But how about passive regen? Passive regen is that primary source. So most people will stop there and say, hey, my DOC is still active because it did that forced regen. But let's take it a step further, because it's that passive regeneration that we want the vehicle to do. So the ECM will record every active regen event, and you need to know what's normal, because again, I mentioned it's duty cycle dependent. So we need to know what the baseline is. So what I had one fleet do, they did that. They downloaded the ECM. They said, oh yeah, our vehicles normally regenerate once every 200 hours. I said, perfect, you have a baseline. They went and the DPF was failed. They put in a new one. The DOC, they inspected it, it looked fine. It passed the active regen test. But then once they put it back on the road, they noticed, oh wow, it's regenning now like 20 to 30 times per 200 hours versus once to every 200 hours. I said, okay, well, what did you guys do? And they said, well, we took out the DOC, we cleaned it, we put it back in again. But when that active regen starts to pick up and it's doing, 2 or 3 times or 20 or 30 times more than normal, that's a sign that the DOC's been poisoned and is asking to be replaced. So 2 things you need to do to confirm the DOC is do that forced active regen, look at the temperature rise, but more importantly, monitor the number of active regens. And if you don't have access to download the ECM software, you'll know if the truck's regenning more than normal. Talk to the driver, and he says, man, my truck's regenning all the time. And if it's regenning all the time, you've had a turbo failure, coolant leak, a batted cylinder injector, that's a DOC waving the white flag asking to be replaced. Because if you don't, you're just looking for a recurring DPF failure to happen. So if you put a brand new filter in conjunction with a bad DOC, it's going to be destined for failure. And that's what we want to avoid. So I spend the most time explaining that. Hopefully I didn't go too far down the rabbit hole, but just wanted to explain those working principles because that's really key in identifying that DOC that's probably most misunderstood and troubleshot on the vehicle. With that going said, we're going to talk about the DPF. It is coded as well. It assists with a little bit of the regeneration, but it's really that DOC that's the backbone to keep that filter clean. So the DPF's like a big garbage can. It traps and blocks all that soot, but the DOC is like your garbage man. It's what works to keep that filter clean and empty. So for example, if I were to throw my garbage on the curb and I come back after work and it's still full, I'm not going to blame the garbage can. I say, hey, what happened to the garbage man? How come he didn't come to empty it? Well, it's that DOC that's the garbage man. It's the one that's keeping that filter clean. So I think that's I can't stress that enough. So you really want to make sure that that DOC is active by looking at those things that I'll reiterate as we go through the presentation. And again, one of the things that we have with Road Warrior, we have free ground shipping and flat next day air rates and second day air rates as well to get you the parts where and when you need it. So why does the DPF fail? We talked about, so here you have the channels. If you look at the inlet side of a DPF, you have closed and open channels. The exhaust gases come through, the particles get trapped inside and then they exit. But then we have some ash that builds up in there, like I said, that gets built up in the substrate. So that has to be physically removed. That's why you want to clean your filter. I would refer to your owner's manual, depending on the model that you have. Could be once a year, could be by mileage or hours, a couple 100,000 miles or as much as 400,000 to 500,000 miles. And if your truck is regenning all the time, you want to ask yourself, when was the last time I cleaned my filter? Because it might just be the ash built up inside the filter that's not giving enough soot loading capacity. And if you have that increased ash, you're going to increase back pressure, put strain on things like turbos, and also burn more fuel. So making sure you clean your filter when you're supposed to is key to keep it operating efficiently. Now, when we're evaluating a DPF, there's some simple tools that we can use because you can visually inspect it. There's 2 sides to a filter that I call. There's the clean end and the dirty end. The dirty end is the inlet side. It faces the engine. So you want to visually inspect that. It should look, all black, covered with soot. The outlet side should look, maybe a little off color. Some of them can turn some different colors of hues with the heat, but there's no signs of soot bypass. So if there's signs of soot bypass, it means that the filter's cracked and you want to replace it. No sense in getting it cleaned. Then the other thing you want to do is what's called pin gauge testing, because this is where you can evaluate your cleaners as well. So if you got a filter that's 12 inches long, you want to get some welding wire that's about 0.32 microns thick, and you want to start checking those different cells to see how far down it's going, if it's being cracked or if it's been damaged during cleaning. So you want to do that pin gauge testing before and after. So you can pin gauge it before. It'll go down, say the filter's 12 inches long, it'll go down to like 11 3/4 inches once it's clean. So before, you can pin gauge different areas of the filter and say, oh, I see it's got 6 inches here of soot and ash in there. Set it off to your cleaner, pin gauge it after and say, oh, wow, look, my cleaner did a great job. It's the pin gauges completely go through. And the last thing you want to do is what's called the high lumen light test. Because if there's, you think, I see some soot bypass on that outlet side, is that actually a filter crack, or was it maybe just dirty fingerprints or greasy prints from the technician? So if you put a high lumen light, some of the workbenches have them, and if you could see a glow, that's just through the plugs. But if you put the light on and you put your head, back and forth across the face of the filter, if you see white light passing through, that's an internal crack, and you also want to replace it at that point in time. Now, obviously, there's DPF cleaning. There's a bunch of different options that are out there. There's a traditional air cleaning as well as liquid cleaning. We are a big proponent of cleaning because that's the most economical thing to do with your filter. Both of them work very well. I would just make sure you use a reputable vendor. And if they're using the air cleaning, all I would say is make sure you're doing a thermal treatment, because the difference between air cleaning and thermal treatment is the difference between clean and deep cleaned. And a DOC really should never need to be cleaned because it's a flow through device, maybe just some air. But a filter does have some what's called sintered and impacted ash and soot, which is just a fancy way of saying, man, I got some soot that's really caked and glued in there. And if you just air clean it only, you may not get that deep cleaning, whereas the liquid cleaning can do that in a much shorter type cycle. So they're both a very good methods to use. You just want to make sure that you're using a reputable vendor to do that for you. Now, the other thing that I caution people from, there are some reman products, and now there's just DPF Recore that's out there. With reman, companies like Cummins even abandoned their reman program, but manufacturers like Detroit and some others still have it. So a reman filter, you can remanufacture DPF. It's basically used and cleaned because it's that core that's the key part of the filter. So when you're remanning, when the OEM's remanded for you, what they've done is they've just cleaned it with their cleaning equipment. So you're paying a premium for an OEM cleaning service. I always say, best thing to do is clean them yourselves. And if you want to avoid downtime, if you have 10, 20 trucks with the same system, buy a spare set, always buy a DPF and DOC, keep them together, and then you can have them cleaned yourself and then put that spare set on the vehicle, and then you can get them cleaned yourself. And then this way you can track and trace them. If you have your own spare set, you can write down the serial numbers and say, oh, this set has been cleaned at 200,000 miles, or this set's been 3 times through the cleaning. But as soon as you do an OEM exchange, you have no history. You could be giving up a filter that had 200,000 miles on it and inheriting one that had 1 million miles back. And then all of a sudden, if you're doing your regen testing or looking at the temperature rise, oh, is that DOC, that reman DOC I got, is it any better than the one I just traded in? Did I miss something, or was that reman DOC just no better than the one I just traded away? The only way you know for sure is to stick with new. And then you have these Recore products, which I definitely would discourage because they're using like a universal core, and they're not doing a direct fit replacement. So I would steer clear of Recore and clean them yourselves and buy new, whether it be OEM or aftermarket, when you're deciding to do so. Then you also can recycle them as well, because the reman program has been abandoned. You might be piling up all these used cores. What do I do with them? We partnered with Cat Rebates. You can call them or just any local recycler. The point is, turn your garbage into cash. So there is money in them. Some of them you can get as maybe $20, but some of the DOCs can be much more valuable, and you can get maybe $100, $200. I've had some customers very pleasantly surprised getting $1,000 or $2,000, depending on how many cores they have. So I definitely would encourage you to do that if you're not doing so already. Then we're just going to get into some pictures here of some of these failure modes like I talked about. So here you can see, this is the outlet side I was talking about. When you can see there's clearly soot bypass and some staining. Here's some staining as well. So whenever you see staining, 2 things you know here. One, this DPS has failed because it's obviously cracked, because that's the outlet side. And when you have soot bypass, you know it's failed. But when you see staining, the DOC's been exposed to that. So you want to ask yourself, as my DOC, is this still chemically active? Has it been poisoned? Do I have a history of a blown turbo, EGR, coolant leak, or a faulty injector? If so, I want to do that temperature rise test and check how often your truck or your vehicle is actively regenerating. Then here, this is what you can't see. This is an example of an uncontrolled regeneration, which we want to avoid. So basically, if you got the filter, it's accumulating that soot. It's piling up. Say the DOC started to fail. Like I said, it's getting weak and it's relying on that active regen. All of a sudden, you got all that soot piling up. There's diesel fuel coming down. The driver has foot on its gas. All that soot is carbon, and it's going to essentially ignite and uncontrollably regenerate and burn the filter from the inside out. So this is why we're seeing that soot bypass, because the filter is melting internally. We did a destructive analysis on this DPF, and this is textbook uncontrolled regeneration. And it was coupled with a failed DOC. So here we had a customer who called us and said, "Hey, you know what? Those Road Warrior filters, we're getting a lot of them fail. So we think we have problems with your DPFs." I said, "Well, funny you mentioned that. You know, you've bought like 40 or 50 DPS, but you haven't bought a single DOC. And the reason why you came to us is because the OEM's DPS were failing as well. So I think we have a DOC issue and no problem with our DPF." I said, "Send us in the DOC. It wasn't ours, it was the OEM one. We sent it off to a third party to do some elemental analysis. And sure enough, that DOC was quote unquote dead on arrival. It was completely deactivated. And that's why the filters were failing, because they weren't being supported with that passive and to a lesser extent the active regen. Once they started replacing DOCs and doing those, using those tips that I talked about, they were able to have the DPFs much less longer, and they were able to fix it right the first time. So again, if your filters are failing, you want to ask why. And I don't want you to forget about the DOC. I mention that repeatedly because it is, I can guarantee you there's a bunch of vehicles running around out there with DOCs that are past their best before date or beyond their useful life. So now when it comes to SCRs, it's a very reliable system, but it does require on the DEF fluid. So the DEF fluid can expire. So I want you encouraged to check and rotate your DEF fluid. It lasts about 1 year, but if it's exposed or stored at high temperatures in sunlight, it can reduce its shelf life to 6 months. So if the DEF fluid starts to break down, you can get crystallization just because the DEF fluid isn't any good. So you want to make sure you take care of that. And also there's air filters, oil filters, and there's DEF fluid filters. So make sure that you replace those when they're supposed to. And there's also, has a very narrow operating window, so too little or too much could cause crystallization issues, and that can be related to NOx sensor failures, because the NOx sensors, when they start to malfunction, they can give bad feedback to the ECM, and then it could be overspraying DEF fluid, causing crystallization, like you can see here in the next slide. This is basically what I call an SCR having a heart attack when you get crystallization. This is something that's enemy number one with SCRs, are probably the most common mode of failure. So the most common thing is poor quality or expired DEF fluid, NOx sensor failure, or exhaust leaks. So you want to basically inspect all that, make sure your DEF fluid is not expired. You also have refractometers that you can test. You want 32.5% concentration of urea, so you can confirm that your DEF fluid is in good shape. You want to visually inspect the DEF dosers and look for signs of crystallization or the inlet to the SCR. And if you're seeing crystallization like that, you definitely have an issue. Could be a faulty doser, bad DEF fluid, exhaust leaks, and the NOx sensors. If the NOx sensors are failing, you want to inspect all that to making sure you want to avoid crystallization. Then once you've checked everything, okay, I've cleaned out the crystallization, my DEF doser looks good, my DEF fluid is up to snuff, I changed the DEF fluid filter, and if you're still not getting NOx conversion, then it could be the SCR itself. Again, it's all interrelated because you have DOC, DPF, then the SCR. If that DPF fails and starts to blow chunks, guess where those are going to flow? They're going to go downstream and damage that SCR. So you don't start with the SCR, but at the end of the day, once you check all the simpler and lower cost alternatives, and if it's still having low NOx conversion, then its SCR replacement would probably be warranted at that point in time. The other thing that we have is a diesel decoder tool. Obviously there's laptop systems, but this is something that we offer very low cost, retails for $350. It'll turn your cell phone or your tablet into a powerful scan tool, so you can read and clear soft fault codes. So it comes with the J1939 9-pin and the OBD2 adapter as well. And the one game changer with this diesel decoder, it allows you to do bi-directional commands such as resetting the ash counter and force regens through the app. So that's something, if you're interested, again, you can talk to Kenworth Northeast about getting your Road Warrior diesel decoder. And now just kind of going towards the end of the presentation, just some fleet triage, just to summarize what we've talked about, things that we can do. I always call it like triaging your fleet, what we can do to take care of things, just to summarize. So like I talked about, one of the things that we want to do is we want to understand passive versus active regen. And if your vehicle is active regenerating more than normal, that's a sign DOC issues. So get a baseline. The ECM records every active or passive regen event, and then you want to break it down to how many regens does my vehicle do every 100 or 200 hours, or if it's something like a school bus or transit bus or garbage truck, maybe how many regens do I do in a day or in a given week, and you have that baseline. Next thing you want to do is you want to look at your flow readings during a forced regen to have a snapshot. If those back pressure readings are through the roof, that's a sign that you may have a filter that's completely plugged up and you want to get in and investigate, maybe clean it or replace it depending on what's happening. You also can voltage meter test your temperature and delta P sensors, your back pressure sensors, to make sure they're functioning properly. Exhaust leaks, that's something that is a very common problem that'll wreak havoc on the after treatment system. So those smoke machines to look for some very subtle leaks can save you some big repair bills. Maybe it's just as simple as a new clamping gasket or an elbow that needs to be replaced that could save you a big repair bill down the line. And those problem vehicles with poor regen history will reveal themselves right away. So, and if you're ever going to be replacing your components, again, always do new. Best thing to do is clean them yourselves and do your own exchange within your fleet so you can track and trace and record keep by serial number. If you do a reman, no sense in keeping records because you have no idea how old that DOC or DPF is. So it's best to buy your own units and get them cleaned with a local cleaning partner. And then some of the cold inspections that we could do is like in the picture before, we could look for signs of crystallization, inspect that to make sure you don't have any signs of crystallization. Use your refractometer to check your DF quality for any contamination and make sure it's at 32.5%. If your DPF has failed, check your service records. Have you replaced an EGR cooler or had a turbo failure or any injection history? If you have, there's probably most likely the DOC's been compromised. We want to inspect that. So what do? We do that temperature rise and look at our regen history. And then those two things combined, don't let me tell you when the DOC needs to be replaced. Don't let the OEM tell you. Let the DOC speak to itself based on the way it's behaving and performing. But you need that baseline data to know what's not normal. The other thing that's very useful is engine oil analysis, contamination. If you're looking for things like sulfur and phosphorus and other things, those are also related to DOC poisoning, so you can get ahead of the curve there. You can visually inspect the delta P temperature sensor. It's usually a tube and it's a back pressure transducer. So you want to look at that tube, make sure it's not leaking, make sure it's not crimped. You can also remove it, make sure it's not plugged with soot because it could give you some false high back pressure warnings, wreaking havoc on your system. Your DEF fluid filter and filter change history. The other thing that's very simple is looking at the tailpipe. If the stack is black, your filter's cracked. So you don't even have to turn a wrench on the vehicle. If you see a black stack, you know you got to look into the after treatment system and make that part of your PM inspection. And then once you've fixed the problem, go out and wash out the stack. So next time you inspect, you know, is that a new DPF failure or something else that happened from months prior. So if you inspect and clean those tailpipes, it's a very good visual indicator because if that filter's cracked, again, it's all interrelated. If the filter fails, you can risk damaging that SCR downstream. So these could quickly be a domino effect. A $2,000 to $3,000 repair could turn into a $15,000 to $20,000 repair very quickly if it's not addressed. And then you also want to review and investigate any fault codes, and you can use your diesel decoder hand tool or your laptop system. So again, at the end of the triage, you want to fix or repair all findings and check for any upstream issues, including the DOC, DPF, and SCR. Assign a team lead, a go-to person to take charge of this, to track and trace all these things, and training your staff and to look for these habits and speak to the drivers. Ask the drivers, hey, is your truck regenerating all the time? Do you notice it's struggling and there's extra back pressure? It doesn't have as much power. Any of those things can lead to signs that you have an underlying issue with your after treatment system. So again, if you've ever replaced a turbo or coolant leak or insulin injector, what's the impact on the after treatment? It's all interrelated. And you know, always use brand new units and reman units. You're getting what you pay for. You're paying a premium for an OEM cleaning service. So if you use reman units, that hard work you could be putting all at risk because the reman unit was no better than the one that you just removed. And if you put this new triage inspection policy into place, it'll definitely maximize your uptime and be predictive maintenance is what I like to say, because the DOC will give you some warning signs. And if it's actively regenerating all the time, it will, if the DLCs will be talking to you, you just need to learn how to listen to those, to look for those signs and signals. And then just wrapping up the last couple slides here, how do you find the correct after placement part? The most reliable thing is to look for the part numbers engraved on the can. Here's a Cummins example, and you want that CPN part number. There's a bunch of part numbers engraved all over it. That CPN part number, that 4394577, is the Cummins DPF module replacement number. And here's a Detroit example where you have that A68049149194 part number. So most of the OEMs have their part numbers engraved on the can. It's the most reliable source to get the correct part. The one problem is Navistar, they don't have them engraved, so you're going to have to rely on the OEM through VIN number to get those cross-reference for you. With that, you can check on our website or just go through Kenworth Northeast and get the OEM cross to a Road Warrior aftermarket replacement. And obviously, we have the largest distribution network. So through our partners, you know, in the red zone is where you get 1 day ground shipping. So you get free shipping on as little as one part. We do have flat rate next year, $175 or $90 for second day air, but as little as one unit will get you free ground. So you can work, a lot of our dealer partners like Kenworth Northeast would have products in stock, but if they don't, we can get them to you rather quickly. Based on we have a New York warehouse in Albany, New York, to take care of the New York State and upper Northeast area. And if it's coming from a further warehouse like Florida or Texas, always free ground. But if you're in a hurry, we can. If it comes in that 2 foot by 2 foot box, you can get it $175 flat or a second day at $90. But always free ground on as little as one unit. And with that being said, just want to thank everybody for taking their time today. Hopefully, I was able to help you learn some troubleshooting tips on that. But I want to thank Melinda and for you taking all your time today. And if anybody has some questions, I'll turn it back to Melinda to see if we have any questions through the presentation. But I want to thank everybody for taking your time today. And if you have any questions, I'll turn it over to you, Melinda.